Hi everyone, this is your struggling CS student here, and today let's solve the weekly premium problem of the week. I just solved the problem of the day. It's easy, it's 1200 rated, it's not that bad. If you want to see me do that question, you can just check out the previous video. If not, I'll take a look at this week's problem. Let's see. Dot product of two sparse vectors, and apparently I've solved this problem before. So hopefully I can solve it today and hopefully cleaner and faster, right? Given two sparse vectors, compute their dot product and implement the class. Sparse vector of nums initializes the object with the vector nums, and the dot product of the vector computes the dot product between between the instance of sparse vector and vec, which is also a sparse vector. Okay, so a sparse vector is a vector that has mostly zero values. You should store the sparse vector efficiently and compute the dot product between two sparse vectors. Okay. Oh, okay. Okay, cool. So immediately what I'm thinking of is we probably only want to, because this vector is sparse, is mostly zero values, then you don't actually want to store the zero values. What you want to do is you only store the values of interest. But then again, you have to do the multiplication, right? Like, so 1 times the 0 here and 0 times the 3 here. So how would you do that? Well, what you would do is you probably can store or expose a public property that stores like a dictionary of indices, right? So you can say like, oh, index 0 is uh, it maps to a value of 1, and then we wouldn't store anything for index 1 or index 2, but index 3 actually maps to a value of 2. So we just need to iterate through the keys of one number with the keys of another number. So and then we say, hey, if that is a match, we can do the computation in that way. But you might have a question like, oh, what happens if I have a key here and they don't have a key here? Then in that case, we can just ignore the computation. Or what if, or like the other way around? So we only care when both when both sparse vectors have the respective index key. So I think we can just do that. So let's do that. All right. So for index num in enumerate nums, we have like a dictionary. D is equals to, try the default bit. I just do a regular dictionary. So we have a dictionary, and then we say d of index is equals to num, right? Now for the dot product, we would say for say d is equals to rect dot d, and for key for index in, oh, actually that's quite bad. Say another dictionary. Not sure if that's like the best name, but yeah, another dictionary. So for index in self.d, now if the index is in another d, then you also want to compute the result. Result is equals to 0. Then we say result class equals self.d of index times another d of index. Then we can just return the result. Oh, return the result. That should be good, right? Unless I missed out something. Has no attribute of d. And oh, I see, we forgot to put the self. Alright, So it passes on the sample test cases. I'm also quite confident that this would pass the that it will be accepted. So let's just briefly talk about the time and space complexity, and then I'll submit the code. And if let's say I made mistakes, we will adjust from there. Okay. So what's the time and what's the let's say the space complexity, right? We only store um well it stores the like it's quite memory efficient because even though like the big O is technically ON, where N is like the number of elements in nums, because we are told that the vector is sparse, then in that case, uh, the space complexity can be, it's more like OK, where K is the number of elements in nums of one that is not zero, right? So it's non-zero values, it's values that we actually care about. Okay, so then what's the time complexity of the dot product method? Well, it's actually linear because we iterate through one of the we didn't iterate through like our own dictionary, right? So then we check, hey, if the index is also in another dictionary, then we can do the computation, and then we done the computation. So it's actually quite efficient because it's only up to ON. So let's take a look at the constraints. It's really not that bad. N is equals to 10 to the power 5, so ON time is actually fine, I think. Now it's advice on your 100 it's not really important. This is the important part. Did they say how many calls will be made to this method? If they're expecting if they're expecting log n time here, that would be quite wow. Okay, so they say, okay, what if only one of the vectors is sparse? In that case, I think we can just do the follow-up here as well. So what I would do is you just check the length of the dictionary and just choose the dictionary. Just iterate over the dictionary that is how should I say, that has lesser keys. So let's just solve the follow-up here. It's really not that bad. So we could say this is the another d, then we say the smaller d, I guess, is equals to self.d if the length of self.d is less than the length of another d, else it will be another d. So for index in the smaller d, right? Then we say let's do revert.d here instead. Another d, else will be rec.d. Oh, then we say another d is equals to self.d if smaller d is equals to self.d, or rather another d is actually the rec.d, else it will be self.d, right? Let me see. Result is 0. Let's put it here. So smaller d is self.d if the length of this is lesser than this, out is the other. So another d is rec.d if smaller d is equals to self.d, right? Else self.d. Okay, I'm not sure how they do this comparison here. If they actually do the comparison by reference, I think it's by reference because dictionaries are by reference. Yeah. So if the comparison is by reference, it's O1, but if they compare the keys and the values themselves, that would not be good. That would be like ON or something. So I guess this would actually work. The result will be smaller d of index. Yeah, let's give it a submit. All right, it works. So this is how we'll answer the follow-up question. Doesn't really change the time complexity. Still ON, right? Because like maybe this smaller d is only has like one lesser element than another d, right? So let's do a quick submit. All right, okay. Except actually the running time is a little bit slower than expected. I thought this would be quite fast. Let me see my previous submissions. Oh, interesting. Interesting. Oh, what the heck? Interesting. Yeah, same idea. It's not super. This is not super hard. Let's see what the editor has to say. This question is quite simple, I would say. Related question. I remember this question being like a pain in the ass to do, but that's another question. Non-efficient. Yep, you store everything. Hash table. Yep, you only store the values of interest. Approach tree. Index value pairs. We can also represent elements of a sparse vector as index value pairs. Oh, it's the same idea. Okay, just gonna show my code again. That's it for this question. Dot product of two sparse vectors. Yeah, thank you for watching and happy grinding.